Number 7 on the Chapter 8 review is a question that really everybody needs to see. So they give you similar pentagons, and they tell you one perimeter is 24 and the other is 30. They tell you the length is 6 of one side, and they want the length of the other corresponding side. If we talked about this concept, we didn't talk about it very much because we were kind of rushing because we knew school was going to be canceled. So the question is, what's the relationship between perimeters of similar shapes and individual sides of similar shapes? I don't think we ever discussed that. Is it the same? Is it something else? You know, do I need to multiply by the number of sides or something like that? So anyway, I would suggest doing a simpler problem, okay? And you know, one of the founding ideas of this entire course is the idea that if you don't know how something works, find a simpler example, see what the pattern is, and then try to extend it to something that's bigger. So I would try some triangles. For example, you know, say you've got a triangle with side lengths of 3, 4, and 5. I wouldn't make it equilateral or isosceles or anything special, just kind of some type of generic triangle. Okay, make a triangle that's similar, maybe side lengths, double the side lengths, for example, 6, 8, and 10. Okay, so the ratio of the sides of these two triangles is 3 to 6. Remember, we have this idea of, it's called the scale factor between the two shapes. Okay, every 3 matches up with the 6. Okay, and that scale factor simplifies down to 1/2. And the question is, you know, do I have to multiply that by 3 to find the scale factor for the perimeters? You know, how does that work? Well, if you try this, this perimeter here is equal to 12. Okay, this perimeter here is equal to 24. Check it out. The ratio of this perimeter to this perimeter is 12 over 24. Guess what? That's still 1/2. Okay, so that implies, it's not a proof, but it implies that the corresponding perimeters of the shapes should be in the same ratio as the corresponding sides. Okay, now by the way, we can kind of do this with pentagons. I don't want to get too complicated here, but imagine that these were regular. I don't remember if the question said they were regular or not. It actually doesn't. It just says that they're similar. Okay, but imagine for a second that they were regular. Okay, if they were regular pentagons, then all of these side lengths could be represented as x. This one has bigger side lengths, but let's say we represented those all as y. Okay, the scale factor from one shape to the other would be x to y, right? Whatever the one length is compared to the other. Okay, if you looked at the perimeters, this perimeter would be 5x. Okay, that perimeter would be 5y. Well, guess what? When you compare the ratio of the two perimeters, 5x over 5y, when you divide out the 5's, simplifies back down to being just x over y. So again, all I proved there was that for regular pentagons, the perimeters would be in the same ratio as the side lengths. But anyway, I think we've seen enough examples here. That's a true idea, okay? The ratio of the sides and the ratio of the perimeters will be the same. But be careful. You saw in the whiteboard activity, the ratio of the areas isn't the same. The ratios of volumes of similar figures is not the same. Okay, that's a totally different ball of wax, and that's something we'll deal with, I think, at the end of chapter 11. But anyway, long story short, really easy problem because you can use the perimeters as the scale factor. So there is a 24 to 30 ratio between these two shapes. You might want to simplify these down. These are both divisible by 6, simplifies down to 4/5. Okay, so there's a 4 to 5 ratio between the small shape and the large shape, and that means there's going to be a 6 to x ratio. If you cross multiply there, you get 30 is equal to 4x. 30 over 4 is equal to 15 over 2, or you could say 7.5. So very important relationship, and even if you kind of guess that, hopefully that's something you kind of sock away in your notes somewhere because you will see it again.